Hello, everyone. Welcome back to the session. My name is Abhishek, and I am mathematics faculty here at askIITians. And this is lecture number 2 of the chapter Direct and Indirect Proportion. In the lecture number 1, we studied about direct proportion. We studied how to check whether the given problem is a problem of direct proportion or not. We did many problems based on that, and I gave few problems as a homework as well in the last session. So in this session, we are going to study about indirect proportion, or we can also say inverse proportion. Both are same thing. But before we start that, it is very important for us to understand the weightage of this particular chapter, both for board examination as well as for your Olympiad examination. So let's discuss that. So if I talk about school examination, guys, then in school examination, you can expect questions which will give you around 8 marks. Okay. It means in your school examination, around 8 marks, this particular chapter is going to fetch you. And this chapter is one of the easy chapter as well, provided that you have practiced a good number of problems, because some problems might not be very direct. They might be tricky as well. Okay. And if I talk about Olympiad weightage, guys, then in Olympiad, you can expect around 2 questions from this particular chapter. 2 to 3, I would say, not exactly 2. So 2 to 3 questions can be expected from this particular chapter. And in Olympiads, the problems will not be similar to what you do in your school examination. They will be like indirect. You have to extract the information which is given in the problem, and then you have to extract the information, right? What is given, then you have to decode like what is given, how to evaluate it, which formula to apply, etc, etc. All that you need to find out yourself before doing that particular problem. So school weightage is 8 marks. Olympiad weightage is, you can expect around 2 questions from this particular chapter. I hope that's clear to everyone. So I think we should move ahead. So which topics are we going to cover in today's session? It's very important to know. The first topic we are going to cover is indirect proportion. Here we will be covering like what is the meaning of indirect proportion? Okay. What is the mathematical formula we have? Okay, like the formula which is going to help us to find out the solution to the problems that we will discuss. Plus we are going to discuss real life relevance as well. Okay, like what are the real life examples, or whether this topic is related to our real life or not. Okay, and here we will be doing the problems that are based on this particular topic, that is indirect proportion. So we will be doing 3 to 4 problems here in the session. The same number of problems will be given to you as a homework as well. So when I will be discussing this topic, wherever you feel you have any doubt, guys, feel free to stop me right there and ask me your doubt. Okay. So before you start any topic, it is very, very important to know whether that particular chapter has some real meaning or not. When I say real meaning, that means whether that particular chapter has some application in your real life or not, or are we just doing it just for the sake of doing, or to get good marks in the examination, to get promoted in the next class. So it's very important to know that before starting any chapter. So as far as this chapter is concerned, and specifically this topic is concerned, indirect proportion or inverse proportion, yes, it has a real life application as well. And first I will be telling you or illustrating you the example that or like what this figure that you can see here is trying to say. You can see this is the source of light. You have a bulb here, right? Now there are 3 positions of a dog. This is position 1, P1 I'm going to call it. That is position 2, we are going to call it P2. That is position 3, we are going to call it P3. What does these arrows denote? This arrow denotes that if you increase the distance, then what is going to happen? Your brightness is going to decrease. Okay. Because what is going to happen, let's say you are at your home, guys, and there is a bulb right in front of you. Okay, so if the distance between bulb and you is very less, then you will see or you will feel the brightness of the bulb is very high. Okay, but as you will move further or far away from that particular bulb, what is going to happen? The brightness of the same bulb is going to appear lesser to you. Yes or no? The same thing they are trying to denote here in this example that if you increase the distance, then the brightness that we have here, that will appear to be decreasing. And if you increase the distance, the brightness keeps on appears to be decreasing. And if you decrease the distance, the brightness, the same brightness that we are talking about here, that will appear to be increasing to us. So can we say that in this example, the distance between the bulb and the dog and the brightness, they are inversely proportional to each other or not? Why I'm saying this? I'm saying this because when we are increasing distance, brightness is decreasing. And when we are decreasing distance, brightness is increasing. Right or not? Means when you are increasing one value, the other one is decreasing. And when you are decreasing one value, the other one is increasing. So there is inverse variation which is taking place here. Correct or not? So in this example, we can say that that brightness, okay, brightness of bulb, that is inversely proportional, is inversely proportional to the distance between to the distance between the bulb and the dog, bulb and the dog, in the top, right? Because if you increase the distance, the brightness will decrease. If you decrease the distance, the brightness will increase. I hope you got an idea of what is inverse variation and how it is related to real life. Let me take one more example which we all must have observed at some point of time in our life. Okay, let us assume there is a construction work which needs to be completed. All right, there is a construction of a building, you can say, that needs to be completed within a particular span of time, you can say. So here, if let's say I have 5 workers, and those 5 workers are going to take 20 days to complete that construction project, okay, but I let's say I need to complete that project in 15 days, that means I have 5 days less. So if I increase the number of workers from 5 to let's say 10, or maybe some more as also, okay. The goal here is, if we are increasing the number of workers, then the time which was initially 20 days to complete that particular project, will that time to complete the project, that would decrease or not? Yes or no? That would decrease, because initially we were having 5 workers, and those 5 workers were taking how many days? They were taking 20 days. But now, how many workers we have? We have more than 5 workers. We might have 10, we might have more than 10 as well. So because we are increasing the number of workers, then it is very natural the time which was initially 20 days to complete the project will get decreased. So here, this situation also depicts the idea, or also gives an idea of inverse proportion or indirect proportion, because when we are increasing the number of workers, the time which is taken to complete that particular project is decreasing. And when we are decreasing, in case we decrease the number of workers, then it's very natural to say that the time that would be taken to complete that particular project is going to increase. Okay, so we can also say, like this was the first case, we can also say that number of workers number of workers, okay, is inversely proportional is inversely proportional to the time taken to the time taken to complete a construction project, a construction project. Okay, because if you increase the number of workers, then it is very natural that the time taken would decrease, and if you decrease the number of workers, the time is going to get increased. I hope you understood why, like you understood two things here. First is how this topic is relevant to your life. There can be n number of examples that we can discuss, right? And the second thing is, you understood or you got an idea of what we are going to cover in this session. Or in other way, I'm trying to say, you got an idea of what indirect proportion is. Please go through it. Ask me if you have any query before we move ahead. All right, done. Okay. All right, so now we are going to discuss the definition of indirect proportion, and here we will be discussing the formula as well, the mathematical formulation of indirect proportion as well. First is, let us understand when does or in which situation we say that the indirect proportion is taking place. Inverse proportion occurs when one value increases and the other decreases. Okay, that means when you are increasing, let's say one value x, when you are increasing x, if on increasing x your if you're increasing x your y decreases, or if on increasing your y your x decreases, then we say that the inverse variation or indirect proportion is taking place. Are you getting it? I'm repeating it again. We say indirect proportion or inverse variation that is taking place when on increasing one value, the other value is decreasing, or on decreasing one value, the other value is increasing. Then we say that the inverse proportion is taking place. Okay. For example, they have given here one example where that's a very good example. In fact, it says more workers on a job would reduce the time to complete the task, right? They are inversely proportional. That's what that we discussed the exact same example right before it, that if you increase the number of workers who are working on, let's say, any construction project, then the time that would be taken to wrap up that particular project, that would decrease automatically because number of workers have increased. On the other hand, if you decrease the number of workers, then what is going to happen? If you decrease the number of workers, then automatically the time that would be taken to wrap up that construction project, or you can say to complete that construction project, that is going to increase. Understood? Now comes the mathematical meaning of it. Mathematical meaning of this. Okay, how do we represent? Okay, notation basically. Okay, let's say you have two values. Okay, you have one value y. Okay, if y varies, if y varies inversely, if y varies inversely to x, then how do we represent it? If y varies inversely to x, then we represent it like this: y is inversely proportional to x. Okay, there are two ways to call it, guys. One way is you can say y is directly proportional to 1 over x. That is one way of saying. Or you can say y is inversely proportional to x. I'm writing both the meaning. You can say y is directly proportional, is directly proportional to 1 over x, or you can say here y is inversely proportional to x. Is that clear? To x. So if you are saying inversely proportional, then you should say x. If you are saying directly proportional, you should say 1 over x. Never say y is inversely proportional to 1 over x. That would be incorrect statement and you might lose marks because of that. Okay, what is this symbol for? We discussed in the last session as well. This symbol is the symbol of proportionality. Okay, this is proportionality. And if you remove the symbol of proportionality, what do we get? We get a constant of proportionality. So you will be getting y is equal to kx, where what is k? K is proportionality constant. K is proportionality constant. Understood? So if you cross multiply, you will be getting xy is equal to k. One second. Xy is equals to k, that is constant. Okay, so we can say that if you have two values, here I have taken those two values to be x and y respectively, and those two values are varying inversely to each other, then the product of those two values is always going to be constant. Understood? Because here I have taken those two values to be x and y, the product of both of them is constant, and here we have denoted that by k. That's the first thing, or mathematical formulation or the mathematical way of representing inverse variation. Now comes the formula that we will be using to solve our problems. Okay, let's say if two quantities, okay, if let's say two quantities x1 and x2 varies inversely to y1 and y2 respectively, then what is going to happen? Then we will have two cases, right? One of the case you are going to have is x1 will be inversely proportional to y1, okay, and you will have x2 is inversely proportional to y2. If you remove proportionality sign, you will be getting x1 is equal to k over y1, and you will be getting x2 is equal to k over y2, right or not? If you cross multiply, what are you going to get? You will get x1 y1 is equal to k, and here you will be getting x2 y2 is equal to k, right? So can we say from the first and the second result, that is from this and this result, can we say that x1 y1 is equals to x2 y2? We can say that, right? And this is the result that you all should know, right? This is an important result, and we will be using this result to solve our problem. So basically, if we have two values which are varying, two values, I have taken those two values to be x1 y1, x1 y1 and x2 y2, which are varying inversely with respect to each other, then what is going to happen? Then the result which you are going to have is x1 y1 will always be equal to x2 y2. So I hope the meaning of indirect proportion or the definition of indirect proportion, the second thing, the mathematical formulation, the third is the formula that we have or that we will be using very frequently to solve our problems. All the three things are very clear to all of you. Please go through it once again and ask me if you have any query, guys. All right, is it done? Shall we move ahead? All right. Okay, so now we are going to do problems which are based on indirect proportion. Okay, so the first problem is the volume of a gas, which we have denoted by V. Okay, this is basically V, varies inversely as the pressure P. So this is P. For a given mass of a gas, fill in the blank spaces for the following. So here P is varying inversely to V. Okay, so we have to find out all these unknowns. So I'm going to call this value is, let's say, x1. We are going to call it x2, x3, x4, x5, x6. Okay, this we are going to call y2. This we are going to call y5. We are going to call y7. So what do we have to find? We have to find x1, we have to find y2, we have to find x4, we have to find y5, x6 and y7 respectively. Okay. Now the thing is, we know if any two values x1 y1 and x2 y2, they varies inversely to each other, then we have this formula x1 y1 is equal to what? That is equal to x2 y2, right or not? This is the formula we have if the values are varying inversely. Okay, inverse proportion, correct? So here, let's say I have to calculate x1. So I am going to assume this value 2 that I have to be y1. Okay, this is my x3, that's my y3. Okay, so if these values x1 y1 and x3 y3, they are varying inversely to each other, then what will I have? I will have x1 y1 is equal to x3 y3 as per the definition of inverse variation or indirect proportion. Yes, that's what I will have. If I substitute the value, I don't know what is x1, so it will remain as it is. What is y1? That is 2. What is x3? That is 60. What is y3? That is 3 by 2. Correct? So this 2 will cancel it how many times? This 2 will cancel it 30 times. This 2 will cancel this 30 15 times. So what is the value of x1 we are going to get? X1 is equal to 3 into 15. So that means x1 has to be equals to 45. Understood? That means x1 must be equals to 45 for this situation to be true. You can see whether it is 45 or not from here. One second. This is here. Okay. You can check. You have 45 as the value. Clear? Now, what do we have? We have to find out, let's say, the value of y2. Okay. So we will have second case here. So if you have to find out the value of y2, you can either compare x1 y1 to x2 y2, okay, or you can compare x2 y2 to x3 y3. It's your choice completely. Answer will remain same. Okay. So here, let's say I'm comparing x2 y2 to x3 y3, x3 y3. This value is going to act as x2. Okay. So I already have the value of x2, which is 48. Y2 I'm not aware of. X3 is 60. Y3 is 3 by 2. All right. So this 2 will cancel it how many times? 30 times. Correct. Now we can cancel this 48 by 6 and this 30 by 6. Right or not? So what do we have? We have y2 is equal to 15 over 8. Okay, that's the value of y2 we got 15 over 8. You can check whether it is correct or not. Here you have 15 over 8 as the value that you can see. Understood? So we got this value as well. And because it's a pressure, that's why you have to write its unit, which is ATM, atmospheric pressure. And when it is volume, you have to write centimeter cube. Okay, so here I should be writing centimeter cube, and here I should be writing ATM, which is atmospheric pressure. Now we need to find out x4. Okay, so to find out x4, what can be done, guys? Anybody? We can compare x3 y3, and this is y4 actually. You can compare x3 y3 to x4 y4. X4 y4. Okay, x3 is 60, y3 is 3 by 2. That's equal to x4, which we don't know, y4, which is 1. So this will cancel it how many times? This will cancel it 30 times. So that means the value of x4 we got is 90 centimeter cube, because this is the volume. Understood? I hope you all are getting how we are doing them. Now this value 100 you have, this value we are going to call x5. So we will be comparing x4 y4 to x5 y5. Okay, so we have fourth case here. You have fourth case. We will be comparing x4 y4 to x5 y5. Okay, let us see what is x4 y4. X4 is 90, y4 is 1. So 90 into 1, you have 90 into 1, that is equals to x5 y5. X5 is 100, y5 we don't know. X5 is 100, y5 we don't know. So 100 into y5. Okay, so what will you get? You will be getting y5 is equal to 90 over 100. Okay, you can cancel this 0 by 0. So what will you get? You will get y5 is equal to 0.9 atm, that is atmospheric. Okay. Okay, all right. You can see here also the value is 9 by 10, or it is 0.9. Okay. So we are done with this. Now we need x6. X6. So to calculate x6, we will be comparing x5 y5, x5 y5 to x6 y6, and that value 1 over 2 is acting as a value of y6, guys. This is y6. So we have fifth case, which is x5 y5, that's equals to x6 y6. So x5 is 100, y5 is 90 over 100 we have. Okay, and x6, let's see what's the value we have to find. Y6 is 1 over 2. X6 is what was the value? That was, we have to find y6 is 1 over 2. This we have to find, and that is 1 over 2. So this will cancel it, like 100 and 100 will get cancelled. If you cross multiply, you will be getting x6 is equal to 90 into 2. So that is going to give you 180 centimeter cube. That's the value of x6 we got. Understood? So we got x6 as well. Now what else is left? We have to find x7. You have to find x7 here, which is this. Sorry, x7 we have to find y7. So we have last case, that is sixth case. In sixth case, we can compare x6, y6 to x7, y7. Okay, x6 is 180. Okay, y6 is 1 over 2. x7 we have 200. y7 we have to find. X7 is 200, Y7 we have to calculate. All right. So this will cancel it 90 times. So what will you have? You will have Y7 is equal to 90 over 200. Okay. So this will get cancelled. So you will have 9 over 20 ATM. That's a value of Y7. Is it clear how we calculated all the six unknowns which were given to us or which we were supposed to find out in this particular question, right? We just used the basic formula that we have for indirect proportion, which says that if you have two values x1 y1 and x2 y2 which are varying inversely to each other, then the formula is x1 y1 is equal to x2 y2. You just need to substitute the value. You have to make sure that your calculation is fine. If you do that, your answer is going to come 101%. Understood? All right. So you can see here, guys, all these values are given for your reference. They did it in the exact same way. Since volume and pressure are varying inversely to each other, so what will you have? You will have P is inversely proportional to V. And if P is inversely proportional to V, you will be getting P is equal to K over V, where what was K here? K is proportionality constant. K was proportionality constant. So if you cross multiply, you will be getting PV is equal to K. So they used the exact same thing here to do all the cases for A, B, D, C, E, F, and G. Like the method and everything is exactly same. But yes, at the same time, one suggestion that do not forget to write the unit whenever you are writing your final answer to be on safer side. All right, shall we move ahead? Okay. Now we have one more problem. These type of problems you will see very frequently in your school examination and in your competitive examination also you will see these type of problems. The concept would be same, but the problems would not be as direct. Okay. What does it say? It says 15 men can build a wall in 42 hours. Okay. How many workers will be required for the same work in 30 hours? So initially, how many hours do we have? We have 42 hours. Now we want this work to get completed in 30 hours. So that means the time which we are planning to allocate for this task is decreasing. And since the time has decreased, automatically it's very clear that you have to increase the number of workers or the number of men. If you do not increase the number of men, then the time taken to cover to complete this task would not, like, it will be original time, like that is 42 hours. So you have to increase the number of men. So we can say that this is a problem of indirect proportion, right? I'm writing the reason here. Since since more number of men more number of men is inversely proportional to time taken to complete work. Okay, right? Since more number of men, that is inversely proportional to the time taken to complete work. So we can say that this problem is a problem of indirect proportion. Without any hesitation, we can say that. So let us make a small table, guys. Okay. Here I am writing number of men. number of men, we are going to denote number of men by xi. Okay, and here I'm writing time in hours. Okay, and we are going to denote the time in form of yi. Okay, 1 2. So 15 men will take 42 hours. So that means x1 that is equals to 15. Time taken is y1 that is equal to 42 hours. Okay. They are asking you what is the value, what should be the value of x2 if the time taken is 30 hours. Okay. So since this is a problem of inverse proportion, okay, therefore can we say that x1 y1 will be equals to x2 y2 here, right? As this is a case of inverse proportion, inverse proportion, right? So if I substitute the value, what will I get? I will be getting 15 into 42, that will be equals to x2 into 30, correct? Or I'll be getting x2 is equal to 15 into 42 upon 30. 15 will cancel 30 2 times, 2 will cancel 42 21 times. So what is the value of x2 you have? x2 is equal to 21 men. That means your number of men should increase from 15 to 21 for the work, for the given work to get completed in 30 hours. So it means you need to add 6 more workers to the number of workers who were already present for this for the time to get reduced to 30 hours from 42 hours for the completion of project. Is it clear to everyone? Please go through it. I'm giving you 30 seconds. In case of any doubt or any query, feel free to ask me. All right, done. Shall we move ahead, guys, to discuss the next problem? Okay. So this solution has been given for your reference. You can check here. They are also saying that direct and okay, the two quantities, because the number of workers you have, faster will they do work. Means if you have more number of workers, the time taken to complete the project is going to be less. So this is a problem of inverse variation or indirect proportion. So the formula would be x1 y1 is equals to x2 y2. These are the values which are given to you. You just need to substitute here. Therefore, it will say the total number of men that are needed to complete the project in 30 hours is 21. Understood? Now we have one more problem, guys. Check out. One second. All right. We have 8 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 6 pipes of the same type are used? See, 8 pipes that we have, they are taking 1 hour 20 minutes, which is same as 80 minutes to fill a tank. And if you are using 6 pipes of the similar type, means the diameter is same, material, everything is same. It's just the number of pipes we have reduced. Then it's very natural because the number of pipes have reduced from 8 to 6. So the time taken to complete this task, that is the time that would be taken to fill the tank, will increase automatically, right? So we can say that this problem is a problem of indirect variation. Correct or not? I'm writing here, since since number of pipes number of pipes is inversely proportional to time taken to fill the tank. Okay, because if you increase the number of pipe, then the time taken to fill the tank will decrease, right? Therefore this is a case of therefore this is a case of indirect proportion. Case of indirect proportion. Okay. Now let us draw the table to list down the values. Okay, here I am writing number of pipes, which will be denoted by xi, and here I am writing time in hours. Okay, that will be denoted by yi. Okay, so we have x1, which is equals to 8 pipes. Y1 is equals to what? 1 hour 20 minute. What is 1 hour 20 minute? 1 hour 20 minute means what? That is same as 1 hour, okay, plus 20 minute. Okay, if you convert 20 minute into hour, what will you get? You will get 1 plus 20 by 60. This will cancel it 3 times, so you will be having 4 by 3 hours. Okay, so that means 8 pipes are going to take 4 by 3 hours. Understood? Now what are they asking? If the number of pipes reduced to 6, so that means x2 is 6, then how much time will be taken? That's what they are asking. So as this is a problem of indirect proportion or indirect variation, we can use this formula, that is x1 y1 is equal to x2 y2. X1 is 8, you can put here. Y1 is 4 by 3, you can put here. X2 is 6, we have this value. Y2 we don't know. So let us solve it. You will get y2 is equal to 8 into 4 upon 3 into 6, right? You can cancel 6 by 2 3 times, and you can cancel 4 by 2 2 times. So you are going to have y2 is equal to 16 over 9 hours. Okay, that means the time that would be taken by 6 pipes of the very similar type, means similar type means the diameter is same, the material is same, everything is same. If you reduce the number of pipes from 8 to 6, then the time taken will increase, and the time that will be taken by 6 pipes to fill the same tank, that would be 16 over 9 hours. I hope it is clear. Please note it and let me know if you have any doubt in this. Any query, any doubt that you have in this till now? Yeah, that is 1 hour 20 minute plus 20. Okay, this is 4 by 3 hours. Clear? All right. So you can see they have also done it in the similar way. Let the required number of time be T hours. So 8 pipes are taking 4 by 3 hours. They converted 1 hour 20 minutes into hours, which is same as 4 by 3 hours. 6 pipes are going to take T hours. Since lesser number of pipes means more time, that means this is a case of indirect proportion. Indirect proportion. Okay. So since this is a case of indirect proportion, you will have x1 y1 is equal to x2 y2. X1 is 8, y1 is 4 by 3, x2 is 6, y2 is t. We have to calculate. After solving it, you got 16 over 9 hours. And if you want to write it in mixed fraction, you will be getting 17 by 9 hour, which is same as 16 over 9. Clear? Yeah. Like this is exactly how you can represent the solution in your examination. All right. So now you have 3 questions that you have to try as a homework. These 3 questions you have to try as a homework, guys. They are based on indirect variation, and some questions might require the application of direct proportion as well. But you don't need to worry about that since we have already covered that. We did problems based on that as well. So no need to worry about that. So these problems you need to try as a homework. And in case you feel any doubt or any query, or you were not able to do any of the problem, feel free to get in touch with your Ask Guidance expert to get it clear. Like we all are always happy to help you out. So before we end this session, let us quickly revisit what all we covered today in today's session. Today's session was actually meant to cover indirect proportion. So we started with the topics that we plan to discuss in today's session. Then first thing we discussed is how this particular topic is related to your real life and what is the real life significance or relevance of this particular topic. We discussed two examples of that. After that, we moved to the definition of indirect variation. We discussed that. Then we discussed the mathematical notation of indirect variation, or how do we represent it. Third thing is we discussed the formula, which is x1 y1 is equals to x2 y2. And you must have observed that that formula, like we applied in all the situations or all the problems that we did to do the problems, right or not? After that, we did few problems based on the application of the indirect variation, and we discussed them in detail. We discussed why the indirect variation, how the formula application needs to be done, and thereafter you are given three problems that you have to try as a homework. Please try them, ask your subject expert in case of any query. And that's it from this session. Thank you so much for attending. Goodbye.